Hello, this is Mrs. Sargent, and this is lesson 4.8, Polarity. We're going to build off of the molecular shapes that we talked about last time, and that is going to help us determine our molecular polarity. So to start off with, just as a reminder, electronegativity is the ability of an atom bonded to another atom to attract electrons to itself. We talked about that with our periodic trends. And so, ionic compounds are going to transfer the electrons to form ions, and they're going to have an electronegativity difference of 1.67. The polar covalent compounds, we've talked about covalent compounds and only that they share electrons. Polar covalent are going to unequally share the electrons between the two atoms, and this is going to create a partially positive and a partially negative sign. So that S-looking symbol refers to partial. The electronegativity difference is going to be less than or equal to 1.67. A nonpolar covalent compound, the electrons are going to be shared equally between two atoms, and there's going to be no charges. The electronegativity difference is going to be less than or equal to 0.4. So to start with bond polarity, you're going to determine bond polarity by finding the electronegativity difference between the two atoms involved. So on your periodic table, on each block on the periodic table, you have your symbol, you have your atomic number, you have the average atomic mass, and then in the bottom right-hand corner, you have another number. Hydrogen here is 2.1. This small number is the electronegativity. I'll just abbreviate it there. So the electronegativity difference is the absolute value of the electronegativity of the first element minus the electronegativity of the second element. This will always give you a positive number. So boron's electronegativity is 2.0, and chlorine has an electronegativity of 3.0. Take the absolute value of that. It has a difference of 1.0. So this is going to be a polar covalent compound because it is less than 1.67 but greater than 0.4. Sulfur has an electronegativity of 2.5 and selenium has an electronegativity of 2.4. This is going to give us an electronegativity difference of 0.1. This is going to be a nonpolar bond. So then I just gave you two elements, but if you have a compound, you can also find the electronegativity difference. So potassium has an electronegativity of 0.8, and bromine has an electronegativity of 2.8. This is going to give us a difference of 2.0. It's greater than 1.67, so this bond is going to be ionic. Chlorine, the diatomic molecule of chlorine, you have two chlorines bonded to each other, so you're going to subtract the electronegativity of both of them, and this is going to give you 0.0. So this is going to be a non-polar bond. So all of your diatomics are going to have non-polar bonds. For CH4, we have more than one bond, but if you look at the Lewis structure, each bond is exactly the same. So you only have to calculate the electronegativity difference once. So the electronegativity of carbon is 2.5, and the electronegativity of hydrogen is 2.1. This is going to give us a difference of 0.4, and this is going to be a nonpolar bond because it is equal to 0.4. So if you have a polar bond, you're going to have a partially positive and a partially negative part of that bond. The high electronegativity is going to be where your partially negative is. The partially positive is going to go with the low electronegativity. The electrons are shared unequally, and so they are going to be pulled towards the atom with the highest electronegativity, because electronegativity is the ability to attract electrons to itself. So that's why they're being pulled here. That's also why we have this partially positive charge, because the electrons are more towards this atom than they are towards this one. So we have a few examples here. We have chlorine and hydrogen. Chlorine has an electronegativity of 3.0, and hydrogen has an electronegativity of 2.1. So we have a difference here of 0.9. This is going to be a polar bond. So since it's a polar bond, we want to determine which is the partially negative and which is the partially positive. Partially negative is going to go with the highest electronegativity. Partially positive is going to go with the atom with the lowest electronegativity. Sulfur has an electronegativity of 2.5, and oxygen has an electronegativity of 3.5. So we have a difference of 1.0. This is also a polar bond. So which one has the higher electronegativity? Oxygen does. That's where the partially negative is going to go. Partially positive is going to go with the lower electronegativity. Phosphorus has an electronegativity of 2.1, and chlorine has an electronegativity of 3.0. So this is going to give us a difference of 0.9. This is also a polar bond. Partially negative goes with our highest electronegativity, which is chlorine. Partially positive goes with our lowest electronegativity, which is phosphorus. So that's how you figure out your bond polarity. A dipole is just saying that you have a molecule that has two electrically charged regions. So you're going to have a polar bond because you're going to have a partially negative and a partially positive atom. The electrons are going to be pulled towards one of them. A polar molecule is a molecule with a dipole, and the electrons are shared unequally because of that dipole. What causes a molecule to be polar? Polar bonds and a lone pair of electrons on the center atom. So what shapes are generally polar molecules? We have linear with two atoms. We have bent. And we have trigonal pyramidal. The lone pair of electrons on that center atom is what's causing these bonds to move away from the center atom, down and away. And that's what's affecting our shape. A nonpolar molecule is a molecule that does not have a dipole. The electrons are going to be shared equally between these because the electronegativity difference is very small. What causes a molecule to be nonpolar is nonpolar bonds and symmetrical shapes. So what shapes are generally nonpolar molecules? Your diatomic molecules. So those are going to be linear, but they're going to be the same type of element. Then we have linear with three atoms. We have trigonal planar. And then we have tetrahedral. How I remember this is it's nonpolar. It has no lone pairs on that center atom. That generally will help you determine the polarity of the molecule. So with our Lewis structures, we can determine the shape of the molecule and the polarity. We have one carbon. Carbon has 4 valence electrons. We have 4 chlorine. Chlorine has 7 valence electrons. So that's 28 and 32. We're going to put carbon in the center because it has the least number of atoms. Arrange the chlorine around it. Subtract those involved with bonding from the total. This is going to give us 24. So we have 24. And then we have to figure out how many do we need. Well, carbon's taken care of because it has 8. Each chlorine needs 6. 6 times 4 is 24. So we have 24 and we need 24. So we can just apply the dots to our Lewis structure. So take a look at that chart on the back of your periodic table on the right-hand side. If I have 5 atoms, I have 4 chlorine, 1 carbon, I have 5 atoms, I have 0 lone pairs and 4 bonding areas. The shape is going to be tetrahedral. And we said that a tetrahedral shape has no lone pairs on the center atom is going to be nonpolar. With carbon dioxide, we have 1 carbon, 4 valence electrons, 2 oxygen, 6 valence electrons, 12 and 4 gives us 16. Put carbon in the center, single bond to our oxygen, subtract 4 from our total, so we have 12. And we need to look and see how many do we need. Well, each oxygen is going to need 6, carbon is going to need 4, so that is 16. So we're short 4, so we're going to add in 2 double bonds. Then we're going to go back and subtract those 4 from our total. So we now have 8. And we're going to reassess the needs of each atom. Carbon doesn't need any. Each oxygen is going to need 4. 4 plus 4 is 8, so we now have as many as what we need. Then we can just apply the dots to our Lewis structure. So we have 3 atoms, 0 lone pair on our center atom, and we have 2 bonding areas. This is going to be a linear shape with 3 atoms. We said that linear with 3 atoms, no lone pairs, is going to be a nonpolar molecule. And then we have phosphorus trichloride. 1 phosphorus with 5 valence electrons, 3 chlorine with 7 valence electrons gives us a total of 26. Put phosphorus in the center, single bond to all of our chlorines, subtract those 6 involved with bonding from our total. So we have 20. Each chlorine is going to need 6. Phosphorus is going to need 2. So we have 20 and we need 20. So we can just apply the dots to our Lewis structure. So we have 4 atoms, 1 lone pair, and 3 bonding areas. This shape is going to be trigonal pyramidal. It has a lone pair, and lone pairs typically make this a polar molecule, which is what this is. And then finally, H2O. We have 2 oxygen, 1 valence electron, 1 oxygen, 6. So that gives us a total of 8. Put oxygen in the center, single bond to each of our hydrogen. We're going to subtract 4 from our total. So we now have 4. Each hydrogen is taken care of, so oxygen needs 4. So we just need to, we have as many as what we need. We just need to apply our dots. So we have 3 atoms and 2 lone pairs. That is going to give us a bent shape. And bent shape is going to be polar. It has those lone pairs. I want to point out to you that from these Lewis structures, if you can draw your Lewis structures correctly, you can identify your shape off of that chart on the back of your periodic table, and then you just need to memorize that lone pairs is going to be polar, no lone pairs is going to be nonpolar. The only other two things, diatomic with two of the same molecule, even though it's linear, is nonpolar, where linear with two atoms is going to be polar. So make sure you work through this practice, make sure you understand how to draw your Lewis structures, and then the shape name and the molecular polarity should come fairly easily for you. And you can use your periodic table to figure out the bond polarity. You have practice on the next page, on page 21. This is the end of our unit, so you need to make sure that you are ready for your test. Thanks for stopping by. Have a great day.